on the computer, not the cloud. And share that one with you. Okay, now if you guys have any questions, please make sure to stop me while we're doing this. Okay. Okay, so collecting network data. So network management refers to the assessment, monitoring, and maintenance of all network aspects. Network management can include the following: controlling user access to network resources, checking for hardware faults, ensuring optimized QoS or quality of service for critical applications, maintaining records of network assets and software configurations, determining what time of day is best for upgrading a router, server, or application. On that bottom one, usually you have to figure out the time window that you are going to affect your users the least. And there are all sorts of, if you want to get into it, there are even all sorts of like math equations that you can do with your traffic if you really want to get into that on your network traffic. Your goals are to enhance efficiency and performance, prevent costly downtime and loss, and predict problems before they occur. It's essential to monitor the following environmental factors: your device rack or room temperature, room humidity, dew point, or barometric pressure. Now, why would it be important for temperature, humidity, dew point, and barometric pressure for a server room? Yeah, what about the hardware? Yep, moisture on the hardware, corrosion, the hardware performance, right? If it gets too hot, that's why a lot of server rooms are usually quite chilly. If it gets too hot, it can affect your server performance, and a lot of servers have multiple processors in them. Then there's flooding as sensed by liquid detectors, smoke or fire, airflow, and that airflow and HVAC, that ties into your room temperature and humidity. Vibration, because depending on the hardware, that can also cause problems. One funny thing about where our server room was located, we had it located in the education center, which was a block, maybe two, away from one of the main railroad tracks in Pocatello. And you could feel the vibrations and hear the trains pretty well through there. So if any of them had been vibration sensitive, we would have had to put stuff in. A lot of servers automatically, if you have room racks, have stuff that keeps them up off the floor for that reason. Motion is sensed by security cameras, or if you have special motion sensors. Room lights on or off, room or rack doors open or closed, and power, main or UPS voltage, battery level, outages, power consumption. A lot of places that have servers have a UPS, which is the uninterrupted power supply. And then the UPS will go to like a secondary generator, so that if the power kicks off, your server just doesn't go boop and, you know, drop everything. Which if it just shuts off with a cold drop, you know, you can lose all sorts of things. And when you power it back on, you can cause all sorts of corruptions and things like that. All right, here's just a example of sensor feed data. And a lot of times you'll have a network monitor that will pull in centralized information for that. And this one, this looks exactly like one I've used before. That's not the same one, but it's, you'll see a lot of them that use that wheel with that same color scheme. So it'd be green is all good, yellow is warning, or yellow or orange, and then red is, of course, danger, danger. So they like to use those, a lot of the same symbols, because that way, no matter what product you're using, it'll come across. Traffic monitoring tools. So network monitor is a tool that continually monitors network traffic. Protocol analyzer is a tool that can monitor traffic at a specific interface between a server or a client and the network. A network monitor can monitor traffic that a single device encounters. However, a protocol analyzer can monitor traffic patterns throughout a particular network. Now, why do you think a protocol analyzer would be important on your network? Are we awake? Protocol analyzers, why are they important? Anyone?
To see where something's going wrong.
Thank you. Yes. It's just like a large network version of looking for patterns of things that you can trace down problems with. Wireless monitoring. Run monitoring software on a computer connected wirelessly to the network. And that can also tell you if you're dropping wireless APs in a certain area, or if you're, it'll tell you, hey, you know, we don't have enough wireless APs because we're constantly dropping signals, things like that. Port mirroring, all traffic sent to any port on a switch can be sent to a mirrored port. Inline monitoring, install a device called a network tap, which is a test access point or packet sniffer in line with network traffic. Reporting, many devices can be configured to report their traffic and other statistics to a network monitor. Yep. A lot of these are basically used for measuring inconsistencies. You're right, German. Okay, so this is just an example of how someone set up the inline monitoring with a network tap. And then you'll see the mirrored port on the switch down here. There's your protocol analyzer down here and your wireless monitor. And so this just gives you examples of how those can be put on a live production network. All network monitoring tools can perform the following function. Set the NIC to run in promiscuous mode to pass all traffic to the monitoring software. Continuously monitor network traffic on a segment, capture network data transmitted on a segment, capture frames sent to or from a specific node, reproduce network conditions by transmitting a selected amount and type of data, generate statistics about network activity. A network monitor or protocol analyzer can use traffic analysis to identify the following: runts, giants, jabber, ghosts, packet loss, discarded packets, interface resets. Alerts might be transmitted by email or text, via SMS, short message service, or they can automatically prompt support ticket generation. Event viewer on Windows. On Windows-based computers, events are logged in an event log that can be viewed with the event viewer application. syslog messages. Syslog is a utility for generating, storing, and processing messages about events on Linux or Unix. The syslog standard addresses three primary components: event message format, event message transmission, and event message handling. Syslog defines roles for each computer that participates in logging: generator, the device that is monitored by syslog compatible application and issues event information, and the collector, the server that gathers event messages from generators. Now, syslogs and syslog messages, there are even products called, there's one that's called a Graylog server, and that basically does the same thing, only it's a product that goes out and takes all of these different types of syslogs from your servers and pulls them into your Graylog server so that you have one place where everything is pooled so that you can look at that information from one point of access. SNMP communications. Organizations often use enterprise-wide network management systems in which the following entities work together. NMS, or network management systems, collect data from multiple managed devices at regular intervals in a process called polling. Managed device, any network node monitored by the NMS. Network management agent, software routine that collects information about devices operation and provides it to the NMS. And then there's the MIB, or management information base, the list of objects managed by the NMS, as well as the descriptions of these objects. The MIB is designed in a top-down hierarchical tree structure, which, as I said previously, you're going to see a lot of hierarchical tree structures when you're dealing with anything network related. So here's your example of your NMS server and NMS application, MIB database, and you can see how it is working with your laptop, network printer, switch, VoIP, and router on this example. Most agents use the SNMP or Simple Network Management Protocol, which is part of the TCP/IP suite. There are 3 versions of it, which are version 1, which is the original and very rarely used today. Version 2 is the increased performance with slightly better security, and version 3 adds authentication, validation, and encryption for messages exchanged between managed devices and the management console. So here's just an example of your managed device, server, and how those might flow. NetFlow. NetFlow is proprietary traffic monitoring protocol from Cisco that tracks all IP traffic crossing an interface where NetFlow is enabled. A NetFlow analyzer or NetFlow collector collates flow records from throughout the network to provide insights into traffic patterns. A NetFlow analyzer can be hardware-based or software-based. A significant challenge with NetFlow is determining the optimal balance between tracking all traffic and tracking enough traffic to significantly observe network behavior. So the problem on that is you don't want to overflow. You don't want to have so much that you can't figure out what's going on because, you know, you have too much information just flooding in, then you can't find anything. But if you have too little, you don't have enough behavior to observe to figure out how that's whatever there's a problem, or to figure out a baseline of how things are actually supposed to work. Okay, so knowledge check. Which of the following is not defined by syslog? Message transmission, message format, message handling, or message security, A, B, C, D. Got 1 vote for D. Lots of votes for D. Okay. Good job. Okay, so like I was talking about with baselines. A baseline is a report of the network's normal state of operation and might include a range of acceptable measurements. And those can be different between networks. Each baseline, and your baseline may change depending on how your network's hardware, software, things are added. So you may need to periodically create new baselines as you change your network. Network performance baselines are obtained by analyzing network traffic information and might include the following: network backbone utilization rate, number of users logged on per day or per hour, number of protocols running on network, error statistics, those are the runts, jabbers, or giants, frequency of application use, and bandwidth usage. Baseline measurements serve as a basis of comparison for future performance increases or decreases caused by network changes with past network performance. Most critical network user functions, more data provides more accuracy. Several software applications can perform baselining. The software ranges from freeware to expensive customizable hardware and software. Common performance KPIs or key performance indicators include the following: device availability and performance, interface statistics, utilization, error rate, packet drops, and jitter. Bandwidth management. Bandwidth management refers to a collection of strategies to optimize the volume of traffic a network can support. These techniques might include any of the following technologies: flow control, configure interfaces and protocols to balance permitted traffic volume with a device's capability of handling that traffic; congestion control, adjust the way the network devices respond to indications of network performance issues caused by traffic congestion so they don't make the problem worse; QoS, or quality of service, prioritize some traffic over other traffic, so the most important traffic gets through even during times of congestion, as there's always got to be some traffic that's more important than others. Flow control is a bandwidth management technique configured on local connection between two devices. The purpose is to ensure the receiver is not overwhelmed with the rate of data transmission. Common approaches of flow control include stop and wait, go back in sliding window method, and selective repeat sliding window method. So here's just an example of this one's the go back in sliding window method. This one's selective repeat sliding window method. Congestion control. Congestion control techniques are designed to prevent congestion before it occurs, called open loop congestion control, and also to remedy congestion after it starts, called closed loop congestion control. Open loop congestion techniques include the following: retransmission policy. Retransmission timers help reduce increasing congestion. Window policy, senders might be required to use the selective repeat sliding window method to reduce the number of frames that must be present. Acknowledgement policy, receivers can be required to send a single ACK message for multiple received frames. Discarding policy, less sensitive frames are discarded so important traffic can survive the congestion. And admission policy. Routers and switches can temporarily reject new traffic that will contribute to or create congestion rather than admitting that new traffic onto the network. And then closed loop congestion techniques, implicit signaling. A sending device detects congestion on the network after experiencing several missed acknowledgement messages. Explicit signaling. A congested network device alters existing data packets to indicate to either the sender or the receiver the network is congested. Choke packet. A router experiencing congestion creates and sends a choke packet to traffic source, informing it of the congestion so the sender can reduce its rate of transmission. And then back pressure, and this is a node downstream from the sender to receiver stops accepting traffic, which transfers the pressure of congestion upstream towards the source. Okay, QoS, quality of service assurance. Voice and video transmissions are considered delay sensitive because they are considered loss tolerant. Preventing delays, disorder, and distortion requires more dedicated bandwidth. QoS is a group of techniques for adjusting the priority a network assigns to various types of transmissions. Optimized QoS translates to uninterrupted, accurate, faithful reproduction of audio or visual input. Traffic shaping, packet shaping, also called, involves manipulating packets, data streams, or connections to manage the type and amount of traffic traversing network or interfaces. Traffic shaping goals include assure timely delivery of most important traffic, offer best possible performance for all users. Traffic shaping can involve delaying less important traffic, which is called buffering, increasing priority of more important traffic, limiting traffic volume flow in and out of interface during specified time periods, limiting momentary throughput rate for an interface. Last two techniques are known as traffic policing. And this just shows like graphs of traffic volume before and after, and you can see how it has those huge peaks. And then they're like, oh, okay, during these times, we need to cap that. And you can see what happens after that time. Several types of traffic prioritization exist where more important traffic is treated preferentially. Prioritizing traffic can be accomplished using any of the following characteristics: protocol, IP address, user group, diff serve or differentiated service flags in an IP packet, VLAN tag in data link layer frame, or service or application. DiffServ, differentiated services, is a simple technique that addresses QoS issues through traffic prioritization at layer 3. DiffServ considers all network traffic, not just the time-sensitive services, can assign different streams different priorities. To prioritize traffic, DiffServ places information in the DiffServ field of an IPv4 packet. The first 6 bits of this field are called DSCP, or differentiated service code point. In IPv6 packets, DiffServ uses a similar field known as the traffic class field. DiffServ defines 2 forwarding types. EF, or expedited forwarding, a data stream is assigned a minimum departure rate. AF, assured forwarding, data streams are assigned different router resource levels. COS, or class of service, refers to a techniques performed at layer 2 on Ethernet frames. COS is most often used to route Ethernet traffic between VLANs. Priority code point, or PCP, is a 3-bit field in the frame header of a frame that has been tagged or addressed to a specific LAN. COS sets these bits to one of 8 levels ranging from 0 to 7. A network's connectivity device and clients must support the same set of protocols to achieve their QoS benefits. Networks can combine multiple QoS techniques, and most usually do, because using just one, most of the time, you can't get all of the bases covered. Plan, response, and recovery strategies. Okay, so if you ever want to know about disaster recovery, I actually did my capstone for my master's program on disaster recovery programs. So disasters and security breaches do happen. Training and preparation can make all the difference in your company's ability to respond and adapt to these situations. An incident is any event that has adverse effects on a network's availability or resources. Could be a security breach, infection, or an environmental issue. A disaster is an extreme type of incident involving network outage that affects more than a single system. So, for example, when I did my DRP plans, I asked if I could do it for the company that I worked for at the time because they didn't have one. And there were one for like the overreaching, but they didn't have any departmental ones, and they didn't have any specifically for the IT department, which is really, really bad. So they didn't have any, like in Idaho, some of our worst disasters are caused by our weather, usually and it's, you know, like when we get extreme cold, and either we have problems with the buildings, we've had problems with pipes freezing and causing building shutdowns, and we can't reach equipment, or we can't reach equipment because there's several feet of snow outside, or, you know, different things like that. Those go under the disaster area. And then the incidents, you can do things like security breaches. There can be things that have happened where we had a chemical spill in the warehouse that caused basically a shutdown because the fumes off-gassed and no one could get near certain equipment that caused an incident. Anytime you get like a malware infection, technically those are incidents. Things like that need to be addressed within your DRP plans and strategies. So incident response, and there's usually incident response teams as part of your plans. So incident response plans specifically define the characteristics of an event that qualifies as a formal incident and the steps that should be followed. There's usually a 6-stage process. It usually begins before the incident occurs, and that is that preparation step. So if you don't have a plan, you don't have that first step. Step 2 is detection and identification. 3, containment. 4, remediation. 5, recovery. And 6, a very important step that I frequently do not see done, review. If you don't review the process. You don't know how it worked. You don't know what steps you can choose to make that process better in the future. And it's just like doing an audit trail for things. The step 6 is everything is cyclical. And step 6, if you don't do that, it means that it breaks that cycle. And in the future, your incident responses are not as good. You would think that a lot of companies would have all of this in there, but there's a reason that cybersecurity and incident response and security policies have skyrocketed in the last 5 years. They didn't prepare. A lot of people were like, we don't need that right now. And they didn't realize how fast moving a lot of these incidents would become. So that's where people like us end up with jobs. Sorry, let go of my shirt. Okay, data preservation. So steps to take in order to safeguard sensitive information, log data, or other legal evidence until the first responder or incident response team can take over, secure the area, document the scene, monitor evidence and data collection, protect the chain of custody. I cannot stress that enough. Monitor transport of data and equipment, create a report. We will go over this in more detail when we do digital forensics, but are any of you familiar with what a chain of custody is? Pretty much, yeah. So a chain of custody is basically a document that is attached to any sort of evidence. And it says, it's very basic, but if you break that chain of custody, or if you don't create a proper one, and that chain of custody is questioned, that's frequently how I ended up in court when I worked for the state police. My job was to teach police officers and lawyers how to package and document so that everything went through court correctly all the way through the case, so that if they questioned the chain of custody, we could say, no, look, here's how it's supposed to be. But a chain of custody has, all this information on the top about where you collected it and everything like that. But the most important part that comes underneath that is, where did you get this? It came from to, and it has your dates, and it seems really pedantic and repetitive, but that is incredibly important. If you do not have that and you do not keep that, there goes any viability of your evidence. So yeah, if you do not have, if you say, I think at any point in time on there, your case just gets flushed down the toilet. Disaster recovery planning. Yeah, well, selfies, it depends, because this goes into digital forensics too. You have to do all sorts of things with the metadata to prove that is a viable there's all sorts of stuff with the court of law. It's a mess. So the best thing to do is to keep your documentation the way it should be. Okay, business continuity and business continuity plans are also part of disaster recovery. Business continuity is the ability of a company to continue doing business with the least amount of interruption possible. Disaster recovery plans detail the process for restoring critical functionality and data after an outage. It should include contact names and phone numbers for emergency coordinators. Now, usually they'll have emergency coordinators, and then they'll have like a tree that says these are the first people and these are who they contact. Details on which data and servers are being backed up, how frequently backups occur, where backups are kept, and how backup data can be recovered in full. Details on network topology, redundancy, and agreements with national service carriers. Regular strategies for testing the disaster recovery plan, and a plan for managing the crisis. Now, those are super basic ways on how to do that. But one of the things that you have to do is you have to sit down with whoever heads your business, and you have to basically say, what are the assets that are the most important for business continuity? And that can be incredibly difficult at first, but it gives you a list of which things are the most important to keep secure, which things are the most important to get up running the fastest. And that is what you want to do with your discovery or your disaster recovery plan. Disaster recovery contingencies. So disaster recovery contingencies are commonly divided into 3 categories: a cold site, warm site, and hot site. Cold sites, components necessary to rebuild a network exist. They are not appropriately configured, updated, or connected. They're basically just sitting in storage. Warm site, components necessary to rebuild the network exist, with some appropriately configured, updated, and connected. That's usually like there's kind of like a base there, and they will need some things added to it. A hot site is components necessary to rebuild the network exist and match the network current state. They are all appropriately configured, updated, and connected. So those are the ones that you can basically switch over in a much faster manner to a new site. So if something happens, like say a landslide takes out a major data storage facility, and you have a hot site that you can switch everything over directly to, that is that's what they mean by hot sites. Mike?
Yeah, earlier I mentioned that my old hiring manager told me a story about like hurricane treated during and one of their sites getting hit. Basically they ended up flying some guy in there like right before the hurricane hit to basically make sure the site was actually up and running during the whole hurricane. I want to say it was like some kind of warp site that they had set up, but he said that the guy was actually sleeping on top of the racks just to avoid the flooding.
I can believe that. Yeah, some of the stories that I've heard from people who go in for DRPs and audits, it's amazing the things that they've had to do. DRAAS, or disaster recovery as a service. There are entire industry people that have seen just a niche environment where their disaster, especially with like COVID and things like this, they're like, hey, you know, we have this niche where we can come in and fill this need. So they provide a highly scalable, inexpensive DR option by establishing basically a cloud configuration that can take over many or most business processes in the event of a disaster. These are not cheap though. So usually you get those with the more major industry players. Power management. Okay, part of managing networks involves managing power sources to account for outages and fluctuations. Power surges can cause serious damage to sensitive computer equipment. Arm yourself with an understanding of the nature of electrical circuit, electrical components that manage electricity. Power flaws that can damage your equipment: surges, momentary increases in voltage due to lightning strikes, solar flares, or electrical problems. Noise, that's fluctuation in voltage levels caused by other devices on the network or EMI. Brownouts, that's what I was having problems with. Momentary decreases in voltage, also known as SAG. And then blackouts, which are complete power loss. A PDU, or power distribution unit, might be attached to a nearby wall, the outside of a rack, or within a rack to connect to the rack's equipment with a power source. A UPS, or uninterruptible power supply, is a battery-operated power source directly attached to the devices to a power supply. It prevents undesired fluctuations of power from harming the device or interrupting its services. UPSs are classified in 2 general categories as follows. Standby UPS, or standby power supply, provides continuous voltage to a device by switching to the battery when it detects a loss of power from the wall outlet. Or online UPS. This uses the AC power from the wall outlet to continuously charge its battery while providing power to the device through its battery. Okay, so I'll give you some examples because the different places I've worked have done different versions of UPS. I will miss the ones that we had with the districts because they had UPS just straight from the wall. So when we had power outages, we were the only people in the building that still had the ability to use our computers because we had to. And we had the generator attached to everything too. So people would usually truck down our hallway and be like, hey, you guys still have stuff that's functional. We're coming down here. So it was really nice. We had the UPS standby power supply. And when I was at the university, I got to watch them do they had like the whole wall unit, and then they had the subflooring one, and they had to rewire it. So they said, if you want to come in and watch them yank everything out and redo it, because we're going to have to basically double what we're doing, you can come in and watch. And it was really cool to watch them pull in all of this power line. And basically they were just like, get out of our way. So they had to yank up all the floor tiles, because the actual floor where they ran everything through was about 2 feet under that. So they yanked everything down, pulled off the huge wall units and everything. And then they had these just massive cables that ran all of the power coax and everything in, and they just had to run everything back out. And it was really, really cool to be able to watch all that. So if you have any friends that are electricians, or if you know anyone that's an electrician and you get the chance, another one for is HVAC people, if you get the chance to go shadow them for a day, it is really good to know, for IT, just to know for physical security and things like that. I've shadowed HVAC people, I've shadowed cable pullers, I've shadowed electricians, I've even shadowed plumbers, because you never know what's going to cross over. And it's really fascinating, because people will pull network cables through just about anything. So knowing how that stuff works and being able to shadow other craftsmen is really a good opportunity. I'm just reading through the comments here. I will say that cable pullers, if you shadow one of them, don't wear good clothes, you will get dirty, and you will end up crawling through a lot of spider webs, and I'm not particularly fond of spiders. So yeah, it is not fun. I felt really bad, because one of the guys I had to come redo all of the stuff when it was an old house that had been done into apartment buildings. I did not know that he was arachnophobic, and there were quite a few spiders under the house, and he ran into a spider nest, and I've never seen a man come screaming up the stairs that quickly before in my life. I felt so bad. But yeah, so wear a hat. Make sure that if you're going to be doing that, don't wear clothes you care about. Exactly. Coveralls are your friend. Okay, so here are some examples of the ones that are on the rack. That's the PDU on the top. There's a UPS system. Usually when you see the in the wall ones, the plugs are a different color, like ours were orange, just so they could differentiate. These are the regular in wall power, and these are the UPS ones. Yeah, I like good spiders, but they had a hobo nest down there. So that's why he was freaking out. But yeah, exactly. Big nope. The wolf spiders, I don't mind, because they eat those. So, and here's some examples of standby UPS versus online UPS. Decide which UPS is right for your network. Here's some things to consider. What type of power you need, required time to keep a device running, line conditioning, and cost. Now, for the required time to keep a device running, what you really need to keep in mind is, generally speaking, you want to be able to get in there and shut down your servers, give them what's called a graceful shutdown period, rather than having them just boop, shut everything off and possibly corrupt things within your network. A generator serves as a backup power source, providing power redundancy in the event of a total blackout. We had a big old diesel one, but I've seen all of these, liquid propane, natural gas. I have not seen steam, I will say that. Generators can be combined with large UPSs to ensure clean power is always available. If an organization relies on a generator, fuel levels and quality should be checked regularly. Ours, we were lucky, it was back because we were backed up to the warehouse and then the bus garage. And the bus garage had its own gas pumps and diesel pumps. So they were the ones that took care of our diesel generator. So we kind of got lucky there. Backup systems. A backup is a copy of data or program files created for archiving or safekeeping. When creating a backup system, keep in mind, decide what to back up, select backup methods, consider your cloud backups, decide what type of backup will be made regularly, decide how often backups are needed, develop a backup schedule, regularly verify backups are being performed. Those bottom two I've seen bite people in the butt several times if you don't do them. The 3-2-1-1 rule defines the following backup principles. 3, keep at least 3 complete copies of data. 2, save backups on at least 2 different types of media. 1, store at least 1 backup copy off-site. That does not mean in the trunk of your car. And yes, I'm using an actual example. 1, ensure that at least 1 backup copy is stored offline. So for the 3-2-1-1, 3 complete copies of data. That is in case you have a major, like a malware, or sometimes you can find configurations or infections that go back through 1 or 2 different backups. So having rolling backups is what a lot of people call those, and having multiple copies so you can go, oh crud, this one's affected too, let's go back a little further, and then you can find clean storage data there. Save backups on 2 different media types. This means that you can save the old way that I saw this was you'd see like your hard drives, and then you'd see those old data tapes. You can do cloud backups. You can do, just as long as they are different types of media, because then you don't have 2 exactly the same things that will cause, like, say, I put this one on an SSD hard drive, this one's also on this, and they won't have the exact same problem with failure. Store at least 1 backup copy off-site. This means that it is not physically on location. Do not put it in the trunk of your car. Even if it's in a fire safe, this is not good. Make sure that you put it somewhere that is, a lot of places you can get, sometimes banks, they'll have, some of the smaller businesses will do like a safety deposit box. There are some places where you can do just offsite storage for backups. And things like that. And then once 1 copy offline, the reason you do that is if you have some sort of online issue and you have it offline, you can fix that problem by bringing the stored data back online. Yeah, technically that is 2 different types of media, but I would pity the person that has to put all the floppy disks back together. But yeah, safety deposit boxes I've seen used quite a few times, especially for like small departments or businesses. When designing contingency plans and choosing backup options, factor in what will affect your decisions. Include the following: RTO or recovery time objective, the time your network can reasonably tolerate an outage; RPO or recovery point objective, the amount of historical data you'll need to be able to restore from backup in response to an outage. Okay, last knowledge check. Which power device prevents a critical server from losing power even for an instant? Surge protector, generator, PDU, or UPS? D. Apparently all the answers are D. The last one was D too. Okay, good job, guys. Are there any questions on anything that we just covered?
Just remember to follow that pattern with all the answers being D for our test.
No, but nice try. So for DRPs and things like that, you will see more of that pop up next year, but that's just kind of your basic introduction to those. Are there any questions about DRP methods, UPSs, any of the stuff that we just went over. Questions about tomorrow's presentations or the test on Friday? Are you all ready to run away? Okay, you'll be sick tomorrow. Nice try. No scheduling your sick days. Okay, so yeah, don't freak. It's just going to be, I don't like group presentations myself, but we have to do it. I'm sorry, guys. So we'll go ahead and do that tomorrow. Normal class time. Whoever wants to go first can go first. And if no one volunteers, you will be voluntold to go first. So just keep that in mind. And if you go first, you're just remember that it'll be done and you can sit there and watch the other presentations. Okay. Yeah, you can do rock, paper, scissors if you want to do that. That's fine with me too. So it sounds like we've got everything covered. We'll stick around if anyone has any questions. Otherwise, y'all have a good night and I will talk to you tomorrow.